I've got some slides on the yeah. Well, he had it. Yeah, we cut out.
And if you can't find one of these words, you can find other
All right, we are hitting on 1 o'clock, and if you're on time, you're late. I've always been taught. So we're going to start. It's 12:59. I have the QR code for lessons from the field for you. So make sure you're in the right place. It's going to be a good one, and we'll have a networking break after this. But I'm just going to turn it on over to these guys. Okay. There you go.
Thank you so much. Hey, good afternoon, everyone. Hopefully, try to not make this too boring. I know everybody just had a full meal. So we are covering lessons from the field, not all the lessons from the field that we probably all have, but I know for probably all three of us, we just kind of picked probably some things that we were dealing with here recently that are causing us some issues and try to figure out some constructive ways to try to work through them. So I'll go ahead and get started. So the purpose of this is it focuses on constructability challenges in highway design, drawing from real-world lessons learned with both roadway and structural topics. We'll explore practical strategies to enhance design efficiency, minimize risk, and ensure smoother project delivery from concept to completion, and hopefully apply these lessons, improve future projects, and prevent these issues from occurring in the future. So three presenters, myself, Liam Shannon, I'm Assistant State Construction Engineer for the eastern part of North Carolina. Robert Bullock will speak after me. He's Assistant Division Construction Engineer for Division 5. And in order, it's Aaron Earwood, State Bridge Construction Engineer. You can see the topics, and we'll cover all of them. So here recently on a few different projects, it may not seem like a big deal, but when it comes to working through a contract and with the contractor, we get into a lot of claim situations about not having all the different pavement types addressed on the plans, specifically as it relates to concrete pavement being hidden underneath asphalt. So I guess the point is that I think that a lot of times in the specifications and in the construction manuals, which a lot of our field personnel, that's all they really reference, sometimes there's a little bit of confusion about what the impacts are to a contractor when they find concrete pavement when it was not supposed to be there, or nonetheless it wasn't pointed out in the plans. So kind of just the point of that is if there's any way possible for us to do a little bit more investigation in these locations to try to pinpoint these things, or at least label them so that they're known and incorporated into the plans, and then we have the line items to address them. So I kind of dug up out of the roadway design manual because I know that's what a lot of the designers see more than what our field personnel do, but section 2.7 says pavement types must be accurately investigated and documented in reconstruction projects, which is like any time, I guess, you're going and working on an existing roadway, doing any kind of change to it where they might have to be removed or altered in some fashion, or if you're going to cover it up with fill material, build an embankment on top of it. A lot of times we have to break it up and leave it in place if it's deep enough. Section 4.4, ensure accurate documentation of cross sections with asphalt, concrete, or mixed pavements. Going to the standard specifications, section 250 is the section for pavement removal, where it calls out the 4 different line items we have: removal of concrete or asphalt pavement, and then breaking up asphalt or concrete. 226, this one is become an issue on a few different projects, especially one recently down east in Division 2, where there was lump sum grading, and in the plans, all that was shown on there was asphalt pavement. There was no concrete shown. I think there's a little bit of assumption that, no matter what kind of pavement they run into in those situations, that it should be covered by the lump sum grading. And a lot of times if the contractors push it hard enough, they can kind of build a good case for that not being something that we can support on our side. So I guess just far as recommendations for addressing this, just trying to get as much investigation done, and if there's any question about whether there might be, and even if it's concrete pavement that might have asphalt, or it doesn't really matter, just know that contractors are going to approach us based on removing the different pavement types. They have different methodologies for asphalt and concrete depending on where it's at, and they can kind of approach you, based on, what their plans were, based on what's in the plans. And so it becomes an argument, and it can cause delays. It can cause, undue grief on the project. So making sure that everything is detailed on the plans regarding that, ensuring proper contractor planning for removal methods and cost, and then as I said before, on section 226, which is our comprehensive grading or lump sum grading, however you want to define it, ensure accurate information is provided to avoid claims and delays in projects with a single grading line item. So just to conclude that, I think I went over everything. Provide accurate, detailed information, and please investigate and label all pavement conditions thoroughly. And accurate plans allow contractors to plan and bid appropriately, keeping the project on track and within budget. Another one that I'm sure some of you have dealt with in the past is we have a lot of these, especially in the urban areas. It seems like we have a lot of these, interchange reconstruction projects or anything that's got complicated phasing on very busy interchanges and things like that, where you're reconstructing ramps, is making sure that the earthwork is compiled not in a totality for the project, but that it's actually broken out for the phasing. I know in Division 5, where I came from and where Robert's at right now, we've had currently 2 projects that are active right now where this has been kind of a big issue, where the earthwork was not accounted for when it comes to the phasing of when material is going to be available. So in general, inaccurate earthwork quantities that don't account for construction phasing can lead to significant project delays and added costs. It affects the availability of materials such as unclassified excavation, resulting in the need for increased borrow excavation potentially, and also excessive waste. So misestimation in earthwork summaries can lead to costly claims. Going back to, I kind of reproduced this slide for the sections of the roadway design manual where this is pertinent. Earthwork pay items, unclassified, and borrow excavation must account for phasing and availability of materials. It does reference it in the roadway design manual. And then another thing I wanted to cover is geotechnical recommendations. Determine where excavation materials can and cannot be used. In Division 5, we have a lot of what is called Triassic material, which we oftentimes do not allow in the top 3 feet. I know in a lot of geotechnical recommendations, they'll say that certain material cannot be used in the top 3 feet, probably all over the state. So I think that I would recommend, maybe because, if that information is created on the design side, make sure that it gets incorporated into the earthwork on the construction side, because I've been on a project before where all that investigation was done, all that information was out there, but the material that was not supposed to be used in the top 3 feet, it was basically just included as earthwork that could be used anywhere. And so that could create a bust in your quantities if you have a diligent resident office or inspectors that are looking into that kind of stuff. Then you can cause a problem there. So so that's what the section 15.4.2 I think kind of points to. So general, unclassified excavation is covered in the section 225, and borrow is covered under section 230. So the recommendations, the earthwork quantities must align with the phase construction to ensure material availability at the right time. So, for example, there's a project that is in Division 5 currently right now where I think about 75 to 80% of the unclassified excavation was in phase 1. You're not allowed to go do anything on phase 2 or 3, pretty strict because of just the way the traffic has to move through the project. And similarly, it's a waste job per the totality of the earthwork. But if 80% of the unclassified excavation is available in phase 1, but 80% of the borrow that needs, or the embankments that need to be, constructed are in phase 2 and 3, we've got a little problem there. So we've had to re-engage the contractor and basically try to find a spot, which is in an urban area hard to find, where we can basically take that unclassified excavation, stockpile it, because no matter what, we're going to get a better price a lot of times on native material from the project, and then create, after bid, after award, a line item for borrow excavation, which is oftentimes a major line item and very expensive. So, and then also on that same project, we have unsuitable material that is not to be used in the top 3 feet. So that just complicated things, and trying to negotiate this with a contractor later on, if you do it before the bid, it oftentimes is kind of, we can provide all that information and it's up to them to try to figure out how they're going to work it in. If you're doing it after the fact, they're going to push it back on us on construction, is that, hey, if this can't be used in the top 3 feet, how are we supposed, and it just gets too complicated, and during construction it takes too long to try to, so a lot of times that might just be considered to be waste material because you don't know how to fit it in. And let me see, the accurate borrow estimation. Anticipate the need for borrow excavation during different phases to avoid both overruns and underruns, specifically at the 15% threshold. So, earthwork items on a grading project are oftentimes major line items, so they will have that 15% underrun or overrun threshold where the contractor can request to renegotiate the price on that. So any of these investigations that are not done accurately, planning for the phasing, for the different materials that can be used in the top 3 feet, it can cause us a lot of issues. So in conclusion, accurate estimation of earthwork quantities is critical for preventing costly renegotiation and claims. The earthwork summaries, must align earthwork summaries with construction phasing and geotechnical recommendations. And proper planning ensures that projects stay on time and within budget with minimal delays and material shortages. I believe that's my last one, Rod. I don't know if you have anything to add to that, but I know that you've dealt with some of those issues yourself.
Thanks, Liam. Yeah, I would just say, sort of to Liam's point too, when we were talking about even phasing for unclassified and borrow, we also have to try to remember in some of that phasing for unclassified, I mean, we're accounting for some of the concrete material, some of the sidewalk, curb and gutter and so forth, and even the rock material. So when he keeps talking about like the top 3 feet too, it's exactly how we're using some of that material and where we're wasting it and so forth. So a lot of that plays into the phasing and what we're looking for, and some of the other items I'm going to talk about will also relay into the phasing issues. So as I get into utility construction, I'm focusing on all wet utilities, basically, the water and the sewer. I know we've talked about, or keep talking about overall general utility relocations, but our main things that keep popping up more, especially in Division 5 and in other areas, is the wet utilities, because we are trying to get all the dry utilities moved ahead of time. So I've got some examples. There's some things we've been seeing in the field, as well as what's tied to design, and a lot of stuff that we've been trying to reevaluate during our design reviews and CFIs. So, as we're getting started and looking into it, each municipality is different. So we're looking into, when we get in the project special provisions for the utility, each owner kind of has their own. We get a lot of copy and paste sometimes, even from municipality to municipality and designer to designer. Sometimes that works, but again, each project is different. We've got municipalities and utility owners that are, some seem to revise their specs, their requirements every 2, 3, 4 years. We've got one specifically in Division 5 that updates theirs every single year. So you can kind of imagine some of our even back and forth between the time the design starts until design project's awarded, that we're almost going back to see if that information has been captured. So we're trying to make sure the project special provisions and even a lot of times that general cover sheet that outlines a lot of their expectations are up to date. We're getting into, do they have the requirements for their as-builts? We've sort of revamped that too with the 2024 specifications for the DOT, trying to lean into that more, but also trying to make sure that our designers, municipalities are being as specific or inserting their language into this, because we get a lot of back-end issues on trying to get the information they want, trying to get them to accept what utilities we've installed. Have we met their requirements? And all this ties back into, are we usually getting reimbursed for what is required in our municipal agreements? So we're trying to make sure we've got the details needed in this plan information. We're trying to review these usually during pre-construction meetings, giving the municipalities and everyone an opportunity to kind of discuss any expectations, anything that's specific in there. But a lot of times, we'll hear during those conferences, the municipality may speak up, or someone, oh, well, yes, we realize this isn't in the contract, or realize this isn't in the details, but if you go to our website or go somewhere else, that it states it on there. But if we're not linking to that information, a lot of times we get to this impasse. We do often list use the towns or the DOT's standards, again, so that's sort of a catch-all, but it's when we get in these items like, we're getting some more information now with some of these plans or expectations that municipalities want. Sort of tried to copy and paste an example of this wet utility installation plan that we've got a few municipalities asking for. And we don't have an issue with that as long as it's in there. I mean, our spec often has covered things like have a pre-construction meeting for boring operations, and both for usually drainage and water and sewer, but they have other expectations they want. Sometimes they want more information, trying to get a feel of how often the municipality wants to be on site and et cetera. So some of them are always asking for not just submit the materials, but they're looking for more of these step-by-step processes. So again, we're making improvements, but these are things we're trying to get everybody to think about ahead of time. Some other items that keep popping up, we've seen these hit or miss, and trying to delve into these more, is we're getting manhole and valve adjustments are part of utility plans, but they're often something that kind of takes place in more of the roadway actions, and the adjustments are often shown on the UC plans. Manholes have popped up on several of our projects and several design reviews here recently that we're calling for adjustments of manholes when it's not just an adjustment. A lot of municipalities have been enforcing for years, again, hit or miss on how well, but when you get over the 2-foot adjustment from the top of cone to the top of ring, it's either in their policy or borderline OSHA of that's as high as you can go before you have to raise up the cone. So it depends on where you are as to how close they're looking. But again, some of the issues we've had is we've had some here recently where it just says adjustments actually shown on the plans. Again, it's on the UC plans as just an adjustment, and come to find out we've got manholes that are needing to be raised 5, 10, 15 feet, and that is well beyond the expectation of an adjustment. As well as it goes back into the phasing process, if the contractor's not expecting that and so forth, we may have already widened the road partially or kind of shifted traffic to a certain way, and how are we managing the traffic to raise up this manhole 5, 10 feet when we're having to backfill up to soil but build up to subgrade, and often put some portion of asphalt over it to do our traffic shifts. Kind of goes back to when we started making changes a little while back about maybe it's just on resurfacing, but we were paying for valve adjustments to be lowered and then raised so we could kind of build part of our either mill and fill, or again, maybe some of our new construction projects, they get paid multiple times for existing, so we kind of build the roadway up and come up and down. But we're really trying to make sure we're trying to do a little more investigation. And a lot of times our cross sections are showing how much the roadway is coming up and capturing that manhole location. So if we know we're coming up 2+ feet, that should be an automatic evaluation of what do we need to be doing with these manholes. Some other items that, I mean, we got an example here, some expectations of, was a little unclear to us on how we were supposed to open cut and install a steel encasement under an existing 60-inch RCP that we were going to maintain. And you can kind of tell that we were expecting to already be 10+ feet deep. So that's sort of a challenge that we had to start discussing and kind of maybe reevaluating. It called for, again, kind of highlight the fact that it said by open cut. Now this was on the, the plans are showing this location on the shoulder, but regardless, open cutting an area like this was challenging, or would be challenging, but also summarizing that a lot of times we get, we're just trying to work around the drainage operations and how we fitting in water or sewer. So a lot of times we get comments like maintain the 6-inch minimum clearance or 18-inch minimum, but there's often seems to be some nuances about, have you considered the type of drainage pipe we're working around and the thicknesses? The 60-inch RCP here has over a 6-inch wall thickness. So if the original anticipation was just put the bore encasement pipe 6 inches below the invert, you're touching. So we run into some items like that, just even when we're phasing it, and you get into, even when we start getting into, do we need a cradle sometimes or pouring flowable fill around it? A lot of municipalities still have minimum requirements on, there has to be some sort of separation between the two. So we start to again run into just evaluating, again, we're all trying to fit things in, but how much clearance do we really have? Can we do any more initial investigation out in the field? On the pre-construction side, how much do we trust? We even on the construction side, as we do as-built at the end of the project, we know the accuracy that we are turning in from time to time. So how well is the accuracy we're relying on from some of these as-built GIS system that municipalities have, especially in networks that could be 20, 30, 40 years old? So how much information can we get to help clarify what's actually in the field currently that we're maintaining and then working around later on? And just a general phasing that we continue to work through. This is maybe one more of the extreme design sides that we try to figure out, but sort of a list of items of manholes and maintaining the manholes in existing travel lanes, installing new manholes in existing travel lanes. We're doing water tie-ins in the middle of intersections. And do we have ICTs for these type of items? Do we have, what kind of detour plans do or don't we have? These are a lot of things we have to start talking through with the construction staff, divisions, and just designers about what expectations are. Because there's a lot of times, things have to be coordinated too when you're doing water tie-ins. So municipalities may be on standby for, they always want their lead time or notifying customers if there's an outage. And an outage isn't always necessary, but we are running into more times where we are doing a tie-in, of course, in the middle of an intersection, especially signalized, because you got a water line that's now feeding off the main line, so that's where we have to install the valve. And the typical water line depth at around, they say minimum cover of 3 feet is, a reasonable, something we can often do overnight. But sometimes when if you're working around on this line, you can see the green is the proposed sewer and the blue's the proposed water. Now we're working around water and sewer in the same area as well as drainage lines, and your water line depth starts to move, or it's just not a simple tie-in because we're feeding around those other utilities. And what happens is this overnight operation almost becomes a 2-day operation or a day-night operation. Again, we're cutting open, depends on the size of your line, we're cutting open, have to take an entire travel lane, if not more. So we start building in multiple ICTs, especially if you have multiple intersections like this. Gravity sewer, force main is also an issue, but again, just general, again, we're looking at depths and trying to tie in. We run into issues with we got to get the road back open a lot of times, especially if you're running, you're running a cross line of drainage pipe. We can lay it in sticks or joints, kind of backfill it and open it back up and keep going. When you're running parallel, that's a whole nother challenge to install it and open it back up, because you're going to have to almost redig the same hole and keep running with it, and different expectations and depths to accomplish all that. So what phasing do we need to do? How long can we get it done? We really don't want to lay 100 feet. Again, this is sort of an exception here, but 100, 200, 300 feet parallel, that's a long time to be in a traffic pattern if you're shifting away from it, as well as you're taking depths into account. If you're in the middle of one lane, you're going to have to pose into the second lane or adjacent lane, maybe for a traffic shift, for shoring operations. Where are we storing our earth material? How are we getting materials in and out of the area? So the phasing starts to become much more important than even a short-term ICT. Again, we're just kind of piggybacking a lot of the phasing that comes into account when we get some of these plans that are, we're looking at the CFIs, the 65% plans a lot of times, and all the TMPs and the utility construction, signal plans, et cetera, all start to come in afterwards. As we all review disciplines, if we're not coordinating everything well, it's kind of relying on construction to group it all together. So just anything we can do to help improve it along the way. So with some of that, we still have, again, some of these may be minor. We get some of the pavement markings and signal coordination overlap. But as the curb ramps continue to grow, basically everywhere that we install them almost, it seems now, as well as, road widening and using existing or improving existing intersections, not just, new location or a complete re-ramp of a corridor. Working with what's already there kind of makes it challenging for installing the curb ramps, but also tying in everything together. And, we have opportunities where, again, trying to coordinate some of the disciplines. And we got some roadway plans. Again, these are just examples of, we have nuances from all, but we have roadway plans that are showing 2, 4, 5 curb ramps, and that doesn't count one that then shows up on the signal plans as a median island cut through, and then the signal plans don't match either one of those. And when we start having the conversations in the field, it's usually the signal plans often are the ones that, of course, because they've been timed and designed accordingly. So now we have to kind of figure out who needs to be changing it, or a lot of times the curb contractor, if they don't see a cut through in that island's already been poured. Similar instances, sometimes they have curb cuts that may already be kind of left open. And so we end up with some rework, but the bigger option is just trying to figure out which plan set we're following and how much, adjustments do we have. So we kind of go back and forth. And sometimes, again, that seems minor, but we get to the point just trying to see which one takes priority. Kind of, again, just some other examples where we get into some conflicts are we installing new or old curb ramps. And again, a lot of times no one's looking at the signal plans till farther down the line. So they're not realizing, are we updating it or not? We may have final asphalt down. We may have some loops that need to be adjusted. And even sometimes the field conditions. Now again, construction, we're doing what we can to fit it in and make our field adjustments that necessary. That's, everyone's always going to be working towards that method, but we're really trying to make sure these are as compatible as possible, so the clarity's there, contractors can bid accordingly, and we don't get the sort of the last minute decision, the confusion in the field to is there or isn't there going to a curb ramp. And even this kind of the signal plan on this one shows new sidewalk being poured, and the roadway and pavement marking plans honestly don't really show, or maybe there was an existing curb ramp that didn't quite meet the standard. So, we take care of trying to update those options, but we're really just trying to make sure we're right, because it usually just leads to at least a little bit of delay of having conversations with what expectations are. And then sort of some minor things we still see. I say minor, but we had one with the pavement markings and the signal plans. The stop bars didn't match or didn't line up. And now I'm sure that's affecting some turning movements. So again, we'll see that eventually. But sort of the other issues is really that the pavement marking contractor is going to come out first a lot of times, because maybe they put down paint or sort of the temporary markings in what they'd say the final pattern is, and then the loop contractor is going to come out and either maybe they look at the signal plans. Sometimes the loop contractor isn't as precise at looking at the signal plans. They just know loops go to back of the stop bar. But regardless, we don't want to be marring up our final lift of asphalt, trying to figure out where the stop bars go. So we'd more than likely definitely go off the signal plans, but it's also something that we'd be making a phone call with the designers or project managers just to confirm where we're supposed to be. But again, just some of the things we're hoping we can just continue to work through, some of the coordinating between some disciplines. And sometimes these things happen too, as over the years of trying to reach out and make sure if the design vision comes through, that again, everything's overlapping. If we reached out to all the necessary disciplines and individuals that just maybe need a cursory review of all the overlapping changes that are being proposed. Hand it over to Aaron.
All right, thanks, guys. So I didn't think that I was going to get very much time to present, but it looks like I get lots of time. So those of you that like structures, I guess that's good for us. Again, my name is Aaron Earwood. I'm the State Bridge Construction Engineer, so happy to be here. Got a lot going on here, like a lot of other folks, but glad to be here and presenting to you guys. When it comes to constructability for structures, we have a very good relationship with our structures management group and our industry partners in AGC. And so I have our subcommittee, and we talk a lot about constructability. So a lot of the things that come out of that group and the lessons learned, we end up implementing through design manual changes or standard drawing changes or whatnot. And so we do a lot of things that are you as a designer may be guided towards. And so I was trying to think through my topics today, and I was trying to think, okay, what would be appropriate, because a lot of the things we come out with that we learn are addressed with Trey Carroll and Nick Pierce and those folks in structures management. So what you see on the screen here, I just wanted to give you a quick update because we have kind of reorganized our unit. We have, there for a long time, we've had divided east and west, and we've had area construction engineers doing both roadway and bridge work. For those that have been around for a while, we used to have our area folks were divided, half of them were roadway, half of them were bridge. We had 7 of each, and it was very effective being able to get out and specialize in the bridge stuff, and then the roadway folks should specialize in the roadway things. With them doing both, it kind of hurt that ability, kind of lost some experience and expertise, and so working with the chief's office, we were able to, and our unit were able to reorganize. So we've recreated the state bridge construction engineer position, which I was fortunate enough to get, and then we've created 4 regional bridge construction engineer positions. So we have 2 in the west and 2 in the east, and between the area construction engineers and the bridge construction engineers, our goal is to really work through those constructability things, hopefully sharing lessons learned like this on a daily basis, helping to train folks out in the field, help the divisions, the resident engineers with whatever they need help with, train them up, and work through projects so the projects can be done efficiently. So you'll see there, again, we just recently, last week or last 2 weeks, we sent out a notification of who the people are. So Aaron Griffith in the 7, 9, 10, and 12. Tyler Rogers, who was a resident engineer up on the Green River project, is going to be 11, 13, and 14. Randy Hall, who was an area construction engineer, has got 1 through 4. And Patrick Cheeves, who came to us from a consultant, is going to be 5, 6, and 8. We're still going to have area construction engineers, as you see. But all these folks are great resources to the divisions, to designers even. Our job is there to help you guys out, make sure that we all work in there as a team. This has opened up a couple vacancies, but or at least one, Randy Hall's position. So, and here's just a little bit more blown up picture of the bridge engineer. So we're hoping that this new setup will allow us to serve you guys better out in the field. All right, my first topic I wanted to cover drill shafts in the coastal plain. It kind of feels weird talking about coastal plain stuff with all we got going on in the West right now, but that's what the topic was, and so we're going to stick with it. So drill shafts, as most of you know that are involved in project development or design or construction, we deal a lot more with our permitting and our moratoriums, and we have very limited times that we can actually work in the water in a lot of these places. Sometimes just a matter of, a few months, 3, 4, or 5 months. And so that really makes it difficult if you have a lot of piles to drive because you don't have a whole lot of time to drive those piles. And so a lot of times the permitting agencies allow us to install casings, and then we can drill throughout the year, even during that moratorium, inside those casings. And so it allows us to continue working, even though drilled shafts are generally more expensive, take longer, but sometimes it allows you to keep working. And so that's a decision that it seems like here lately, a lot of the projects have gone from what would have normally been a pile project to a drilled shaft project because for that specific reason. But again, they are more costly generally. There's a lot more issues potentially that can go wrong. But again, it allows us to continue to work. Piles, when we can do them, are obviously preferred. Generally, is going to be a cheaper option, a little bit faster, less risky, depending on the conditions. But sometimes we have subsurface that will give us a problem if it's not down deep enough to where our minimum tip is. Trying to get through a dense sand layer or something like that can cause problems with pile driving, and so that may lead you to drilled shafts or maybe some kind of pile excavation, pre-drilling, spudding. It can get complicated, but that thought process and discussion and investigation on what option we go with needs to happen thoroughly. We've been working through on the Alligator River project with the CMGC through this very issue, trying to figure out what the best type of foundation is, and it's been a great process. We've done a pile, losing my words, pile investigation plan, test pile program, test pile program to determine could we drive through this layer, what is it going to take to get through this layer, bunch of soil testing. So that to a lesser degree will happen on a lot of projects, but those decisions need to happen early. So getting into what I was going to be talking about, when we do end up deciding to go with drilled shafts, we need to be, and this has kind of come to light here lately on some of these projects, and it's not the first time we know about it, but it seems like it's been more of a concern lately, is artesian conditions. So we've been running into that, and it's caused us some problems on some recent projects. So this particular project is something that we have been under construction for a little while. The plan was to have drilled shafts, 7 bents, 3 drilled shafts, 4.5 foot diameter, and very tight moratoriums, which is the reason why we went with drilled shafts. And unfortunately, there's an airport close by, so we're limited on our ceiling of our cranes and drill rigs and so forth. We could not have anything sticking up above that ceiling at elevation 95. So we knew that was going to cause some issues, but we felt it was constructible with the drilled shafts. And contractor installed all their casings. So there's, again, 7 bents, three drill shafts at each bent. So we got 21 casings in the ground so that we could start drilling. They built their work bridge, and so it's got fingers at every single bent, so fingers going off for each work bridge. So a lot of work and time and effort and cost went into the work bridge. Contractors' means and methods, they got their drill rig sized appropriately to construct it, and they start drilling on the first shaft at bent 1, and they're drilling. They get down a certain distance. They're using slurry construction to support the sidewalls of the drill shaft, and they get home at night, and they come in the next morning, and slurry is just kind of flowing out over the top of the casings. So we realized at that point that we've got artesian conditions. So I think at that point we ended up putting in flowable fill into the casing to try to just stabilize the sidewalls because we didn't want it blowing in. So they filled it up with flowable fill to a certain elevation, and then we ended up welding. Actually, we may have welded on casing first. So we welded on. We were originally just above the work bridge, and they ended up welding casing on another stick of casing, and it continued to come up over that. So we got Geotech or a consultant to come out and put a piezometer in to check what the artesian head pressure was, and so it turned out to be elevation 18, so which was 4 feet above the work bridge, right? So you can see where the water in the river was, and then what that head pressure was from the artesian conditions. And so you think, okay, well, 4 feet above where the work bridge is not too bad, right? But to maintain a positive slurry level above it to offset the pressure of the artesian, generally we like to be at least 5 feet above that. And then in talking with Geotech and the contractor, with us pulling our auger up, in and out, losing slurry, we ultimately decided that we needed to have casing at elevation 28 feet, which was 14 feet above the work bridge. All right, so now a lot of these drill rigs, you want to have your casing no higher than the top of the track so they can go in, get back out pretty efficiently. But some of the rigs are very limited on the headroom to get up and over a casing that's 14 foot up above, drop back down, drill back out. We did have a rig that we thought could do that, but then it was going to be up in the airspace in the elevation of 95, which we could not get into. So it created some significant constructability issues with this artesian head. So ultimately, we ended up we went around different drill methods. We had experts from contractors. Geotech spent extensive time working through this with us. Ultimately decided that it was really, in this case with all the factors, was not even constructible with drill shafts. It was just not going to work. So we ended up having to switch to pipe piles. So we had to redesign. Contractor's got all his casings in the ground, all his cages tied for his drill shaft. Work bridge designed for a certain elevation and everything, and had to switch to 30-inch pipe piles, went around with that, got the redesign. So now we have to basically get rid of all the reinforcing steel, pull the casings, order all the new pipe piles, and basically a huge renegotiation of all the original work. We're shut down for 3-4 months because they can't do anything until the moratorium's over. So huge project impact, right, because of this artesian. And generally, the artesians that I've been involved in are not this bad, this impactful, but this goes to show you that it can be. So this is just kind of a quick view here of the work bridge. And again, you can see all those fingers. So it's a lot of effort because we did talk about modifying the work bridge. Can we raise it? Can we do some different things with it? But there's a lot of cost and engineering that goes into that work bridge. And so they've based that on the plans. And I guess I forgot to tell you, the plans did not include artesian conditions. So I guess that was a key point that I'm assuming that you took without me saying it. But we did not show anything artesian to be expected. But it was there. And I will say, in talking with Geotech, because I'm not an expert on this stuff, I was like, how does this get missed? And so as you may or may not be aware, they go out to do their investigation. They may be drilling from the bridge, right? And so they're way up here on the bridge, up 20 some feet up in the air, and when they're drilling, they're not going to necessarily notice that artesian head pressure that's down at a certain level down below where they're drilling. Or if they're up in the embankment, they may not recognize that if they're not looking for it specifically. So it can be missed, and it was missed on this one. So again, the revised project impacts, we had to redesign a 30-inch pipe piles, several months of delay, a lot of leftover materials. It's going to be, I don't know what the final cost, a couple $1 million extra, maybe more of extra costs because of this one little thing. So that just kind of shows you how things lead to very expensive changes. So this, in addition to a few other projects that Geotech and the divisions are working towards, led to a memo or a kind of a blast from Geotech. You probably saw it on September 11th. That didn't sound good. They sent out an email on September 11th, basically talking about the artesian potential. So basically reminding people, amongst a few other things, measure static groundwater levels at potential artesian water elevation. That could be open boreholes, monitoring wells, like standpipe, or a vibrating wire piezometer. So they're reminding folks that are doing these subsurface investigations to be on the lookout for those artesian conditions, particularly in that coastal plain. And it goes on to talk about that they need to review the potentiometric surface maps on all projects in the coastal plain. So you can see the link there at the bottom. And so there's different aquifers that are in the coastal plain, and each one has different maps. And it shows you what the potentiometric head is on those aquifers. You can see the star where the project was located. And so there was potential there, even though it didn't show up in the subsurface investigation. And so that's basically the point is they need to be reviewing these maps as the designer and as the driller to make sure to anticipate what is anticipated and then do what it takes to make sure that that is verified. If the artesians don't show up during the investigation and the potential is on these maps, then Geotech needs to be contacted and work through that and discuss what other investigation may need to be done to address that. So again, and then the engineer, whenever you're designing or your foundations, needs to consider how those artesian conditions are going to affect constructability, and what foundation type. Maybe the head so much that we decide it's not worth it to do drilled shafts, so we go with piles and deal with the issues with that. And again, thinking about constructability through that. So again, some of the things that the artesian conditions can affect, work bridge elevations, right? They would have designed their work bridge higher had they known artesian conditions existed. Casing elevations, how much casing they need to bring, because that's a cost. Their means and methods, those are all things that go into the impacts from that artesian. I have this note on here that we kind of came up with in talking with Geotech. Obviously, there'll be guidance on standard notes and so forth. But basically, when there are artesian conditions, we need to let the contractors know what to expect, right? And then there'll be a elevation that the contractor needs to, it'll say that they have to anticipate artesian conditions to this elevation and anticipate it casing to at least 5 feet higher than what that artesian condition is shown. And then we also wanted to clarify for our contractors that our specs say for permanent steel casing, which we're in the river, is going to be permanent casing, that we pay from the top of shaft to the bottom of the casing. And so if they're having to weld 5 additional feet or 10 additional feet, this clarifies that even if they cut that off, that's incidental to the operation. So that's kind of what that note's going to clarify. So work with Geotech on that, but that's the specifics on that. So we've dealt with this before. Had one Cape Fear River, Elizabethtown. We knew it was there. We put the plan note on there. Everything went fine as long as the contractor can plan for it. So, all right, staging and work area. So this this topic I just wanted to kind of throw out there. It's not very technical, but a lot of you are involved in planning for projects and roadway alignments and traffic or temporary detours. One thing that, I've kind of got some feedback, from contractors, just asking around, hey, what's some things that make, your life difficult and so forth. And, one of the things I heard back was having enough room to do the work, get materials delivered. Those are things that we need to be thinking of. This picture I was just able to dig up. I'm sure there's a lot tighter work zones than this one, but this was a detour, and you notice it's in a curve. So this particular project, you can see the crane there, so that's going to eat up 30, 40 feet there from the bridge, unless they're right up to it. Getting material delivery, right? They're going to be bringing in pile hammers, with 80-foot leads on trucks. We got this curve here, the crane, the tractor trailer, the pile leads, other material delivery. Getting in and out safely, and then safety of the work crews and the public, for that matter, for the traveling public, it's very difficult. So they were obviously able to build this, and again, we can build it when we need to in tight spaces, but it's something as a general discussion point on every specific project to be thinking about that. Could this detour alignment, maybe you had to temporarily impact the wetlands 5 or 10 feet more? And I know some of y'all probably cringe when I say that. We just got to make sure we're doing things safe, and you got to weigh all the alternatives. They ended up having to use a temporary signal on this one, which was not originally anticipated, just because it was so tight getting in and out. And they ended up using that for the duration of the project. And so, again, I put they had around 150 feet there in the bottom, you can see. And generally, you would think, okay, that's plenty. But again, it can get very tight, and there's tighter work zones than this. But when possible, we need to allow extra room and be thinking about that. What can we do to provide access? What can we do to have staging, getting in and out, and being able to safely build the project, because that's priority number one. So I know these are discussions that are having, but I just wanted to kind of reemphasize that, make sure we have enough room. All right, temporary access. So those area construction engineers and regional bridge construction engineers generally is one of their duties is to help with this access and determining on a project how a contractor is likely going to access, to set cranes, drill rigs, and so forth. And so they're really our point person to help with that. I know a lot of division-let projects, sometimes those decisions may be made on your own. If you don't include them, they are a resource on all projects, central or division, so please use them. And y'all can talk through this, work through this, but it doesn't always happen, so I just want to make sure that I share this with the group. So generally, you're looking at a causeway or a work bridge or barge access, right? We have to think through that on every project. Sometimes you don't need temporary access. You can set the beams or the box beams or girders or cord slabs from behind the indent. But generally, that needs to be thought out on every single project we're building a bridge on. And so things that you need to consider, and I always used to consider and tell my folks to consider when we're looking at access, is to be as flexible as possible and provide alternatives when possible. Every contractor does not have the same equipment. They all have different size cranes. We can generalize and kind of have an idea what a lot of them have, but they have different size equipment. Every project's a little bit different. But when we can provide access that allows this contractor that may have this smaller machine versus this one that has a bigger machine, allow that access to where either one could bid on that job. Don't just leave it and require a contractor to rent a 500-ton crane to set that thing. If we have the option to get temporary access where we can get in a little closer with a smaller crane that maybe they own, it's going to save us money. If the contractor chooses to use a big 500-ton crane and set it from behind the indent, that's their option, right? They may save the money that they were going to put on the riprap in the Class 2 causeway and use that for their crane. That's the option. So now you got a bidder that has a smaller crane with a causeway, one that's renting a big crane. That's competitive. We get better costs, and give better options. So another thing to think about is with the work bridge versus, say, a causeway. Some places in the state, we know we have to put a work bridge, or we know it's going to be likely a barge, right? But there's sometimes where a work bridge or a causeway might work, right? And so generally, I like to recommend a causeway when I think it can work, because it's a lot easier if the contractor chooses to use a work bridge later to get permission from the agencies to switch from a causeway to a work bridge than it is if we show a work bridge and say, now we're going to dump a bunch of riprap in the creek, right? So if we can, if a causeway is a viable option, and that's something that may be the most effective, I will generally recommend a causeway. And then if the contractor says, no, we're going to put a work bridge, pretty easy change, right? So just something else to consider. We want to all be cognizant of and respectful and mindful of those environmental conditions. But we use a lot of causeways, and sometimes that's the only option. But again, it is easier to switch from a causeway to a work bridge. Also with the openings, being flexible on where those openings are. A lot of projects will, show causeways from both sides, and there'll be just a general note that says, don't exceed more than 50% at any one time. That's for hydraulic opening or to make sure, or sometimes for boat traffic. I like that, right? It gives the contractor the option. They can go either side. One experience I had recently in a division, we had a work bridge, and we wanted to show a work bridge all the way across the river and allow a certain width opening for boat traffic, and let the contractor have flexibility. It's actually the same bridge I just presented on, and allow the contractor to say, okay, anywhere between spans, B through D or through E, the contractor can maintain a certain size opening for boat traffic, right? You'd think that would make sense. The contractor has a little flexibility. They would not allow us to do that. They made us select the opening location, which limited the contractor's options because they might have wanted to bring in more girders from this side versus this side. So now we have to go get a permit mod if we want to change it. So I can't wrap my head around why they won't let you, but sometimes they won't. But I guess my point is that when you can have flexibility on those types of things, try to get that. It seems like it makes sense to me. But that's that. So flexibility, allowing the contractor within certain limits and guidelines is something we want to shoot for. And then again, I've already mentioned about can I set this up to where I can maybe even use two smaller cranes versus one big one? Having that flexibility is always good. So again, I led off with the area construction engineers and the regional bridge construction engineers. Please call them. That's their job responsibility, and they're going to be doing that and helping you. But if you have a division-let project and they've not already been plugged into that, please give them a call. They would love to help do that. All right. Now we're going to turn it back over to Liam for some post-construction assessments.
So yeah, the closing topic here is something presenting for Value Management Unit. I think we have Zach and Allison are both here from Value Management, and maybe others. They kind of produce these slides, and I'm just going to kind of go through them. And if you have any questions at the end regarding this, you can definitely direct your questions towards them, probably more than me. But so what is a post-construction assessment? They kicked off. They're a fairly recent thing. They started off in 2021, and they're, I've been in, I guess, probably 4 or 5 of these at this point. They're held after we've basically closed out the job. It's about a 2-hour Teams meeting generally to make it easy for anyone to make it, depending on where they're at. If the designers are not in the area where the project was. Includes personnel, NCDOT, and external from all project phases. I think that would be construction unit is generally involved in these on the structure or roadway depending side. The division that managed the project, their construction folks will be involved in that from resident engineer, potentially down to assistant resident. Maybe if there was, a heavily involved inspector on it, anyone can be invited to that, and then on up through division construction engineer or anybody else within division. Obviously the contractor can be involved in that, and the design team. And it's a lessons learned exercise to try to, grow and develop from, the good things and the bad things, all. So, and it can be started by anyone. So, constructability review. I've also been in probably like a little bit less of these, 2-hour in-person meeting near or on the project. Meeting held during the design phase of a project. The purpose of a constructability review is to bring the design team, construction team, and AGC selected contractors together to discuss a project's constructability challenges. And I know when I've been a part of these, there's maybe been 2 or 3 different contractors who might be interested in bidding on the project eventually, but we basically call them in there to kind of give us any ideas they might have as, before bid, like what kind of issues do you see with this? Is there anything that you recommend as a change or any kind of problem that you foresee? Because we rely on the contracting industry to kind of, tell us what, is this even possible? Seek solutions to these challenges, elevate quality, and potentially reduce risk. Same as the post-construction assessment. That process can be started by anyone. So they want to hear from you. Your insight matters and can help on the design of construction and future projects. There's the email, contact information. I think I have Zach at the back of this presentation, his contact information as well. He's a good resource to get the process started if you wanted to do it. And in conclusion, hopefully, the purpose of today's session was shared practical insights and lessons learned from real-world NCDOT field projects. The lessons have been gathered from challenges encountered and solved across various construction disciplines. Continuous improvement. Applying the lessons discussed today can help prevent recurring issues, improve project efficiency, and minimize risk. Post-construction assessments play a critical role in that, and ensuring that lessons from completed projects are applied to future ones, fostering continuous improvements across NCDOT projects. And looking forward, use these insights in your own projects to enhance collaboration, avoid costly delays, and improve overall project delivery from design to completion. And thank you, and I think we did pretty good, 159. So we'll take any questions if there are any. Yes?
On the work bridge and the opening at 50%, who was the big day on the permitting side that gave you more time to try to allow flexibility?
Gosh, I can't remember. Honestly, I can't remember which agency that was. I don't know if that was Coast Guard or CAMA maybe, or I don't remember honestly. But yeah, it was.
It comes up a lot in like the design build projects, and I know I know it's definitely like almost like a rule of thumb that seems like everybody sticks to. So it's definitely agencies like Army Corps, people involved in that.
And I'll just say, just in kind of tag on that, the post-construction assessments. We used to say all the time we would be having a problem with anything like a joint type or something, and we would have an idea and we'd say, well, we should try this, and then we find out that 25 years ago they did this same thing, and we got away from it, right? Well, there was a reason we got away from something, because something didn't work. And so to avoid going in circles as an agency, right, and doing the same mistakes over and over again, that's the whole point of just this whole program of clear and post-construction assessments, to share what we learn in the field and why we're making these changes and why, and documenting, telling people, so that the future engineers, the young engineers, aren't saying, well, hey, we should try this, and I'm retired, and we tried that 25 years ago, and it stopped, it didn't work for this reason. Maybe you can make improvements on it, but those are the types of things to try to share with others. And those post-construction assessments, you might not have been the designer or the resident engineer on that job, but they're open to anyone, and so you can sit in and hear what happened on that project. So hopefully they can be implemented, or the same mistakes not made on other jobs. So as the different units, hopefully we're taking those information and making changes to our details or our standards, or maybe it leads to a spec change or something. But as a designer, those things that you have control of, or making those decisions on certain things, that allows you to learn from that and hopefully not make the same mistakes. So I encourage you to join those as much as you can, and hopefully get use out of those. So. Any other questions?
spoke about the staging areas during the design phase. So one of the things that we're tasked with is being efficient as we can with the design, reducing right-of-way where we can, not having those increased impacts, and then we paint you guys in a bad position. So, or put you in a bad spot. So is there guidance on, is there anywhere we can go to bring somebody early in on the design phase from construction that may help guide us to give you guys a little more room to work?
Yeah, and I mean, I know I'm throwing this out there and saying there's not like a specific one case fits all anything, right? And so I know that you're having those conversations already, right? I'm assuming so with the divisions, you know, the DCEs, the assistant DCEs, you know, the area construction engineers can get involved as well. You know, I've been involved with some, and we've just gone ahead and reached out to contractors and say, hey, you know, is this amount of room going to work for you? Do you need more? And so I think it's one of those things that's a topic, but I don't have the answer for you except for consider that, right? Right away is expensive. We don't want to impact. We're trying to minimize, you know, impact to wetlands and streams and so forth. And I'm not telling you just go buy a bunch of right of way or just, you know, get into the stream and buy a bunch of wetlands, because I'd probably get fired if I told you to do all that. But consider it, right? I mean, a little bit more take to give a little bit more room in certain cases may make sense. So I think it's case by case, and letting the, you know, the divisions be involved, the DCEs. You know, we can be involved as much as possible to try to help each situation and say, yeah, we feel like we might need a little bit more room here for that, or this, you know, that's okay. That's just really just have those good conversations about that, and just recognize, like this one, it looked like there's plenty of room, and they were able to get it built, but there was no consideration for the temporary or the permanent lane closure on the project they ended up having to do to build it safely, right? And being in a curve, again, made that one worse. So those are just things to consider, I guess. No magic answer for you. I can't say you have to have this amount of room.
Just name drop. Aaron, you're with.
Well,
Yeah, so would a constructability review help in that situation? Because you bring the contractors in?
yeah, you know, I don't know on that. I mean, that was a pretty straightforward project. So I don't know that a constructability review is necessary. We talk to contractors all the time, and it's not a formal constructability review. So, you know, I'll like I said it before, I'll call a contractor and ask them, hey, you know, what do you think about access for here? You know, what size crane would you have to do? Or, you know, is this going to work for you? We can have that without a formal meeting. We can just have those conversations, or we can just, based on our experience, look at it. So on that particular case, I would say probably not, because if we do that, we'd be doing it on every project, and I don't think that justifies that. You get the complicated projects, or if it's really, you know, tricky access, yes, constructability review. But this particular one, I would say no.
Say the smaller projects would be harder, and correct, I mean, would that be what you would think, Robert? The smaller projects is where you're probably the amount of space that you might acquire would be a lot less. You know, you're just doing a simple bridge replacement. Yet, you know, it's really driven towards trying to minimize the impact.
Right, and like, for instance, we have one, I don't think it hasn't light yet, we had a similar conversation, like culverts. Like, we maybe it's like a turn lane widening, but was affecting a culvert location near an intersection, and of course, I mean, I think not a whole lot of fields, maybe the invert of the existing culvert, or having to extend it maybe some 10 feet below elevation, but that's there is no access down one side. And, you know, limiting right away, trying not to really impact one side significantly other than it's already there. So that is something that's like, well, we need to be able to provide in our phasing then again on maybe shifting traffic over and making sure they can get down there. So you know, the smaller projects are definitely the ones that create more, as well as just to circle back around to the dry utility relocations. Where are we putting those in the same instance that are now impacting, trying to get some access to, even if they're out the right of way, access and overhead movements also a concern. So,
Allison?
I would just say, just kind of piggybacking on all of that, absolutely, like an informal construction review, contacting your construction unit and getting them to look at stuff, like a specific issue, or there's a question, you know, that you kind of just, you're wondering about this particular thing. A constructability review, in my mind, like a formal one that we're going to facilitate, you're looking at multiple issues. Like, there's a lot of stuff to consider, and kind of like to your question, like, you're weighing all these options, and which option are you going to choose? And so you bring in all of the experts to
Yeah.
So please do talk to the construction unit, but yeah, if you do those formal ones, it's, there's a lot of different things going on.
Yeah, and I would say every single project should have a constructability review. It may just be you and the divisions, or the designer talking about it, thinking about constructability as you design it. It may not be an official in-house constructability or contractors, but every single project should have some constructability review or thought out on that project. So that's kind of the take home for that.
You give the construction folks some guidance on when they coordinate with construction resident and when they coordinate with construction area folks?
So as far as the designer, if they're working for the division or working, then I would say generally, especially consultants should go through the proper channels. But structures can call me. They call us. There's a process for for getting access, right? Recommendations done. So structures will send that to the area construction engineer or the regional bridge construction engineer. I'll field a call from anybody, but I think going through the proper channels of going through. If they're working for the division, going through there, and then them reaching out to us to get us involved is probably appropriate. But I don't know if that answers your question. Is that?
I think a lot of times, I mean, to where, I think in the construction unit, which usually the divisions that are driving this, and so I think we a lot of times depend on, outside of the structure stuff, we depend on the divisions to kind of bring us in, potentially on a lot of that stuff. I mean, we would like to, if you can, with the map that we have, we'd like to have every area construction engineer engaged on their respective division projects and stuff like that, but generally it's going to be division construction and division itself that's driving these projects. So we're there, again, just kind of for support, but we don't actively get engaged, I guess, unless we're asked. So, but I don't think there's nothing wrong with just copying the respective area construction engineering.
Oh yeah, definitely copy. But I mean, certainly go through the division if that's who you're working for, or central units if they're so forth. All right. Well, thanks everybody for the time and attention. We appreciate it.
All right, thank you, gentlemen, for lessons learned. We're going to have another